Hey there, Nick Jatakis here. In this video, we're going to go over the value of creating checklists for high-stakes changes, or basically workflows where the consequences are pretty bad if something goes wrong. So in this video, we're going to go over a use case of performing a database upgrade. We're going to be creating a checklist for that. Now, in this video, we're not actually going to be performing the database upgrade. It's kind of going to be more of a retrospection of a checklist I already created. We executed this in production. And yeah, I'm going to be going over this blog post that I wrote out here. And by the time that you watch this video, this blog post will be available. Right now it's on localhost, but I'll leave a link to this one in the description. So yeah, use case here specifically is performing a database upgrade. We performed a major database upgrade in production for a large application here. So yeah, checklists clearly can be used for more than just database upgrades, of course, but after going through this post and video here, hopefully you'll be able to see the types of things I broke out into steps, and then you can apply them back to your use case. So yeah, there's a reason why airline pilots use checklists, even if they have something like 40 years of experience, doing takeoffs and landings, right? Having that workflow right in front of your face really lets you focus on executing the steps at hand with absolute focus instead of trying to think about the workflow creation while executing the steps at the same time, right? These are two very distinct things. Actually executing the steps with laser focus versus like just trying to figure out, okay, what do we do now? Is it step 1, step 3? What about this? Should we do that? No, that's all the hard work trying to define that workflow here. So in our case here, one of my clients, they wanted to perform a major database upgrade from MySQL 5.7 to 8, and we wanted to minimize downtime and overall risk, and also just minimize in general, like what could possibly go wrong. Needless to say, checklist, pretty valuable there. It let us do all the hard work, right, of defining the workflow while there's absolutely no pressure at all, well before the time the upgrade actually happened. We also get a chance to test the workflow in a test environment before applying it to the live database, right? Just having that workflow defined, something you can just execute from top to bottom. It's a repeatable workflow. So it's really nice to be able to do that and not deviate from it in production here. So yeah, it's basically a test environment, right? So yeah, let's go over this database actual upgrade workflow here. Now, this was on AWS using RDS. This is AWS's managed MySQL and Postgres service here, but similar steps could be used just about anywhere if you happen to be watching this video specifically for performing database upgrades. But again, think back and try to apply these things to things you may be using checklists for. Maybe I'll do some more videos about different use cases around that. But yeah, after all the steps here are listed out, we'll go over the details of all of them and like my thought process along the way. Kind of just want to go over the steps first and then thought process later. And by the way, there's going to be a couple of links here for different steps here. I added them there, but in reality, these led to actual resources being acted on in a step here. Like for example, when we go to, modify the live database, like this actually led us right to the RDS database page in Amazon's web UI here. But yeah, I'm not going to link to that stuff here. So they actually go nowhere. So no need to click on them. But in my opinion, this is a very important concept here because, this just helps avoid human error, right? You don't need to go somewhere, click somewhere, make sure it's the right resource being modified, go to this tab, then click this thing and the other thing, like live on the fly while you're executing the workflow. Nope, just having the link there lets you click it. The hard work of verifying and ensuring that the link works is all done beforehand here. It's a minor detail, but useful in my opinion here. So steps 1 and 2 here. Let's make sure that you can actually connect to your live database before doing anything. And step 2 here, confirm that the SQL user has all the necessary permissions to run any queries afterwards. Actually, since we're on video here, I think it's going to be easier just going through the explanations while we're going over the steps here. So I think it flows a little bit nicer, but it was a little bit harder to make all that work in text here. But yeah, making sure that you can connect to the live database before doing anything, really useful, right? Here, steps 1 and 2, critically important because, you can get to step 9 here, which spoiler alert was like just running some queries after the database happened to make sure things work here. But yeah, steps 1 and 2, they guarantee that your database user can actually connect to the database, which is going to be an important thing to do later on here in step 9. And you also don't have any issues with various permissions. Like for example, maybe your database user can only read, write, and update to a specific set of tables or for a schema or something like that. But one of these queries over here needs to do something else in a different schema that you might not have access to. This actually happened in our test environment and it was a blocker for a bit because we had to contact the right person here to be able to modify the SQL user's permissions to be able to run that type of query. And in this case, I was the one who created and executed all these steps, but I don't have permission at the SQL level here to modify a user's permissions. Also, step 1, again, is really nice just because it's a good idea to ensure that your system is in a working state before you modify it. As a reminder, step 1, just make sure you can connect to the database here. Now, steps 3, 4, and 5 are dealing with enabling a maintenance page on our domain here. And that is through AWS's firewall here, but any other firewall could work as well here. So the idea here is we want to be able to block live traffic to example.com before we start the process of doing all this, because this major database upgrade with MySQL at least is going to be a downtime event here. Hopefully not too long, 10, 15 minutes, etc. But in this case, we need to modify our maintenance page message. We also need to enable the maintenance page on the domain itself at the firewall level, and then verify that the maintenance page is being served just by going to example.com and making sure that that is good to go here. And yeah, steps 3 and 4 or 5, handy way just to toggle maintenance mode on a site without needing to perform any type of code change. It's basically a firewall rule that you can turn on and off on demand. You can do it for one or more domains here. It only takes a couple of seconds to apply. I kind of like this process. It worked out very well for us, and we've used that a lot in the past here. Step 6 over here is to create a manual database snapshot as a backup. And let's name it, example. And in our case, we're doing an upgrade from 5.7 to 8. So I just named it pre-MySQL 8 here. We're doing the upgrade, and I put the times, year, month, day of the actual name of the snapshot. Again, it's nice to have these details predefined. I don't need to think about the name, and I can just, click over here to go directly to the database page on RDS, and I can just make a snapshot by clicking the button there. Kind of nice. And we'll see that you can automate some of the stuff using Terraform or, whatever infrastructure as code tool that you prefer to use. But for now, they were just links here, and someone executed them, which were myself here. So yeah, step 6, mainly just an insurance policy, right? In case something goes wrong. And we want to make sure that we have the latest version of our database to ensure no data loss here. That's why we had to turn maintenance mode on before we even made the snapshot, because making the snapshot itself takes a couple of minutes. You're just waiting around for RDS to dump that thing out to whatever format it's saved to on disk on RDS's end. But yeah, maintenance mode gets turned on first. Live traffic is now disabled on the site. Then we make the snapshot here. Now, step 6 and 7 here, step 7 here is just modifying the actual database. This is, I guess you could say, the scariest part, right? It's literally performing the update on the database here, but we just need to tell RDS like, hey, by the way, we want to update to this specific version of MySQL. And there's this idea of a parameter group here. Basically, whatever custom MySQL options you want enabled, we created this custom parameter group beforehand. But going back to mentioning step 6 and 7 here, this idea of creating the snapshot, but also maintenance mode being on first beforehand, it's not a flawless scenario here where the database absolutely will not get modified after maintenance mode is turned on. Because think about your web application. If you happen to have background jobs running at some point, like maybe a job will execute in the future while maintenance mode is turned on, but you're still creating the snapshot, something like that. Like your database doesn't go offline when the snapshot is being created. So if a future background job happened to have created something that modified the database, like your database could technically have been written to after the snapshot creation has been made. And now you have a little bit of a data discrepancy here. But, we've got pretty good robust logging and observability in place here to know when that type of thing happens. We also have ways to reconcile all that stuff and, make it right in the end. And again, we only have an issue here with that use case with the job stuff if we actually need to use a snapshot, meaning like something went horribly wrong, we need to revert everything and go back to the snapshot. And, because if a background job runs while the database is actually down, like waiting for RDS to perform the update, then those background jobs are going to fail because the database won't be up, so the connection won't be able to be made, and then the job's going to fail, and then it'll just be retried with some exponential backoff, and, eventually the DB is going to come back and things are going to work here. So yeah, this is kind of just like clicking buttons here, and then, while all that happens here, step 8 is just waiting around, looking at the status page for RDS. Kind of just called it out here as a reminder to myself, when I was executing the steps, that this may actually take 10 or 20 minutes. It's a good idea just to, stay around, like, reload that page a bit, check out the different states here, because if we go down here, step 8, oh yeah, I should have mentioned too, like step 7, mainly just clicking buttons in a web UI. That's just modifying those settings there. That custom parameter group was created beforehand in preparation of the update, especially when we tested it on a test database as well. And, I go on to mention here, like some of those click buttons in web UI steps could totally be put into code using Terraform or another tool, and then they can all become independently pull requests that can be reviewed and merged in order. But yeah, this client has a 10-year-old application, and not everything has been ported into Terraform yet. At some point, well, that stuff will. And yeah, step 8 over here, just as a reminder, jumping back up, it's kind of just a waiting game, right? And I wrote a little more details around here. The AWS config tab for the RDS instance, it kind of shows the status, such as, if it's applying a new parameter group, or, maybe it's in the process of rebooting. You get get all these details with, pretty good response time of, you'll see like, I don't know, little badges get changed from red or gray to red, little things like that. But I did notice that the time range of this is pretty sporadic. So sometimes the upgrade took 10 minutes, sometimes it took about 20 minutes. And that really had nothing to do that we can control. Different points in time just had different numbers. That's purely on RDS's side. So, it's kind of nice just to have a range here. Also really good for just figuring out, going back to business owners or stakeholders to try to figure out like how much downtime is actually going to happen on this one. You want to account for things like how long is it going to take to make a snapshot? How long is it going to take for this and that? And, when we tested it in a test cluster, that we were able to get good times and everything worked. And we'll get to those details a little bit afterwards in a second here. But yeah. Once all of this happens here and your database is updated, then the next item in the checklist was, connecting to the live database and just running a couple of different SQL queries, right? This is why it's really important that step number 2 is accurate here and you're able to perform these things here. Now, I just put in some dummy SQL, select, whatever, but it's really nice, this really demonstrates the pattern though. Like, you'll want to have your expectations here. Like, what do you actually expect? Like when you, query for the SQL version, well, you should be getting, this version back, or maybe this table, if you perform like a delete will be empty, like, whatever it happens to be, right? These are very domain specific to your application here. But going back down to step 9 here, basically just a couple of sanity checks here to make sure, correct versions of things and whatever tables need to be cleared or updated, based on whatever the dev team suggested there. So then steps 10 and 11 here are basically just disabling that maintenance page and then bringing back the site here and, just verifying that the site is actually loading successfully here. So if we go back to steps 10 and 11 here, this allows the site to be live again, within a couple of seconds of enabling it. And, verifying could be a human thing, but it also could be automated smoke tests, right? You can automate step 11, going to various different components of your site, making sure they exercise certain tables or problematic things that you may expect that could pop up if you were to perform a database upgrade. But you could also automate those in code here, making some automated smoke tests here. But right for now, it was just the human went to those pages, made sure that they actually worked, and then everything was good to go, at least on paper, right? But then, one step here, and again, it's like a minor detail, but sort of important, right? Like, let's create a calendar reminder for ourselves to delete the manual snapshot in 30 days, maybe 60 days, 15 days, like whatever your criteria happens to be. We were pretty comfortable with a month here because realistically our database is pretty big. There's over a terabyte of data and it is ever changing with a lot of different customers and things. So it's not like we're going to just come back in 28 days and use this snapshot as our source of truth. This snapshot is more just like, hey, if something went wrong and we need to actually determine what went wrong, a developer can take the snapshot, spin up a test database in complete isolation from production and debug against that to see what's up, right? That's the value of having that snapshot there. And I think I actually talked a little bit about that here around step 12. Yeah, because snapshots do cost money to store there, right? They're just sitting on disk, taking up storage, even if they're not actively associated with a running instance. And if you've got a 1 terabyte database there, and I forget the exact cost offhand, was it like 1 cent per gig or something like that? Like, it costs money to store these things here, but we wanted to keep that snapshot around in case we needed to restore it pretty quickly here. We could have done a SQL dump and just stored that in S3, and that's going to be like an order of magnitude cheaper or something like that. But spending a couple bucks a month, literally what it is, I don't know what it would be like $10 a month, something like that, just to keep that snapshot around is totally worth it. Because if something goes wrong, we want our developers to be able to very quickly spin up that DB. And if this process here saves them half an hour of doing a SQL dump import or something like that, then that half an hour versus the $10, like, it's not even a drop in the bucket, very much worth it. But, it is very worth pointing out here that this is a temporary resource to be deleted. So it's not like, we're not going to be hanging on to this forever. And then, the last step here, notified the business that the site is back up here. And always nice to know here, in our case, everything went flawlessly here. Had about 15 minutes of expected downtime, and we did that during a time where our traffic usually dips. Now, it is a site where there is 24/7 traffic, but you look at different charts and graphs, you can always see some dips in your traffic there, at least for us. So we did it on one of those, which was basically, when exactly did we do it? I think it was like 8:30 Eastern time on Monday or something like that. But yeah, the prep work paid off basically. Now, you will notice though, in those steps that we just took a look at here, there are no steps or workflow for if something actually goes wrong. That's because I both wrote and executed the steps personally. At this point, I was kind of just okay letting my overall general experience like troubleshoot anything that may have went wrong, right? If I were writing these steps for someone else to run, that would be a little bit different. I would have added more details, maybe even screenshots and some other stuff. Maybe it would have pushed me harder to convert all of that RDS modification stuff and firewall stuff into Terraform even if that wasn't a high priority beforehand, right? But that wasn't the reality of this situation. This situation was, me making the workflow and me executing them as well. So I also, to preface this a little bit too, like I executed all this stuff in a test environment multiple times to work out the kinks. By the time it was actually executed in production, I was feeling really good about it, right? We saw an example of that here in step 1 and 2, where the user didn't have the correct permissions to perform one of these queries here, and that was ironed out in a test environment. And that's why I added these 2 steps here, because if that would have happened in prod and we didn't have a test environment or something like that, this could have been a blocker for quite a bit, especially since we were doing this a little bit out of hours. The only one person who actually has permissions to do this, maybe they wouldn't be available. Now, realistically, if that scenario did play out, they would have been generally available because they would have been aware of this thing happening here. But still, this could be an extra 5 or 10 minutes of being blocked. And if you're talking about a 15-minute downtime, an extra 5 minutes to be 20 minutes, it's actually a really long time. So you want to really iron that stuff out if you can here. But I will say this, we did have a disaster recovery plan, right? It wasn't like a formal document or anything crazy, but we thought about like what could go wrong if certain things go wrong and like what would we do to actually solve them. Realistically, I think I wrote step 8 here is the one that's problematic, but it really is a combination of basically steps 7 and 8. I'll probably modify the blog post for that right here, but it's basically just waiting on RDS. Like, I hope the upgrade actually works. Like, there's not really a lot that we can do there other than wait around and just hope that RDS as a managed service is doing what it should be doing here, looking at the status and verifying the results there. But yeah, so, while it's happening also, I did execute all those steps there. I did just create screenshots of various things here and quickly jotted down like timestamps and, how long something took, because I think that's a really cool idea just because, once the entire process is finished, it was like step 1, make a screenshot, spend a couple of seconds writing down the timestamp here, because now when the whole process is finished and everything is good to go, there's no pressure, everything is nice, I can go back there and make a little post with a timeline that mentions anything interesting that might actually have happened along the way, right? This really, really helps your future self or someone else understand the process in case they need to do something similar in the future. Who knows? Maybe you'll be doing another database upgrade in the future a year from now. Now you're going to have this nice little checklist and, workflow as well as, evidence or proof or what actually happened here with a little bit more details, right? When performing the scary update, having the extra context and details, totally well worth the 15 minutes or whatever it takes here to write up that summary here. And I, in my opinion, think that is very well time spent. And the rest here is stuff that I'm going to fill out after I make the video here. Now it gets a little bit meta because the video is not done, not edited, no timestamps yet. But yeah, let me know in the comments below, right? Like, when was the last thing you made a checklist for? Or if you've performed a database upgrade for a SQL database where you did end up having a little bit of downtime because maybe you don't have any like read replicas or any advanced application logic that lets your app run without the database being writable, something like that. Yeah, let us know in the comments below here. And with that said, if you like the video, please give it a thumbs up because it really does help a lot. Thanks a lot for watching, and I will see you in the next one.